Good afternoon or good morning, everyone. It depends on in which part of the world you are now. My name is Lenka Kleger, and I would like to welcome you to the webinar, Autumn Coloring Through the Eyes of Scientists. The webinar is organized by GrowApp Regional Coordination Office for Europe and Eurasia as a part of the European Phenology Campaign, which is now coming to its final part. I would like to introduce my colleague Dana Votapkova.
Hello, nice to see you.
Hello, Dana. Dana will take care of smooth running this webinar. The webinar is planned for 1 hour or maximum 75 minutes, depending on how many curious questions we will have. So many of you joined the Phenology Campaign and you observe the autumn change of trees. So I can say that you are real experts on green down in your locality. And in today's webinar, we want to bring another perspective of the autumn change, the perspective of scientists who work with the data that you collect and upload to the GrowApp database. We will hear presentations from two special guests, scientists and educators, Arnold van Vliet, who is a phenologist from Wageningen University in the Netherlands, and Brian Campbell, the lead of the Trees Around the Globe campaign and NASA Science Education Specialist from the United States. So warm welcome to both of you, and thank you very much for joining us today. First, I would like to give word to Arnold van Vliet, who will talk about the relation between autumn coloring and carbon cycle, and about the way how your contributions to GrowApp help in the scientific research. So if there are no questions from the audience, I think Arnold, you can start.
Thank you very much, Lena, for this introduction, and for the organization, also Dana, for your enthusiasm and your continuous support for this autumn campaign and the GrowApp Phenology Campaign. So that's always very nice and inspiring. And also nice to see you all present in this meeting. Nice that it is possible. Nice that we can work together like this and get into personal contact. And that is because there is also a human face to this research, and that's what I also very much like about GrowApp and citizen science, working with volunteers, not only students but also volunteers throughout the country and the countries, because we have a really international network going here. I have a little bit of a cold. It's not Corona. I tested yesterday and we are quite apart from each other, so no risk for infection. But anyhow, I had to hurry. I just had a television recordings for the news later this afternoon about autumn coloring also, but also about the way people are disconnected nowadays more and more from nature. And I think that is also a way how this phenology campaign helps in showing people that nature is beautiful, that nature is changing, and that's what they call this a study in Europe, noticing nature. So if you really look more carefully to the plants and animals around you, if you listen, if you smell, then you really start to care more intense, and it will affect your health. So it's not only good for science, but it's also good for health and well-being if children, but also adults, watch the plants and the season changing around them. Interesting research, maybe also to share later on. I'm going to share my screen. Oh, but I'm not able to do so. You are the host.
It should be okay now?
Yeah.
Yes, it is possible now. Let me find the right one. This one. Can you see it?
Yes, perfect.
Great. So the importance of studying the timing of autumn coloring, that's what what the title is of this presentation. And I will try to address a number of different things with some beautiful pictures there of this birch tree. The importance of leaf coloring and leaf fall for the trees, and also different scientific or different applications of why this information and having information on the timing is important. climate change, CO2, and the role of plants in the whole CO2 dynamics, climate dynamics that is taking place. Then, of course, I will zoom in a little bit more on the GrowApp and some trends over time. There I will specifically focus on the Netherlands because I have most data and most experience there. I'm also coordinating the Dutch Phenological Network already for 20 years now. And we have historic phenological observation, information on the timing of life cycle events like autumn coloring since 1868. So we also have a nice reference from the past. But let's have a global look first. We're all familiar with climate change at the moment in Glasgow, the COP conference of parties, the people all over the globe working together, trying to see how they can solve the climate issue. And I just saw a report from the World Meteorological Organization who stated that October 2021 was the third warmest after, I think, 2019 and 2015, if I'm correct. But here we see the globe average, the difference in the average temperature of the warmest years, of the 6 warmest years. And you see that 2015 is the warmest so far, with a 0.9 degrees Celsius warmer than normal. And normal is in this case 1951 till 1980, the average temperature over that 30 years average. 2016, the second warmest. That was the warmest. 2015 was the 5th warmest. And you see that 2020 was also the warmest, together with 2016, with 1.02 degrees Celsius higher temperature than the average. So it's ongoing and ongoing, and interesting that is because of the increase of the greenhouse gases. That's no surprise to you all. I always like this picture where we look at Hawaii, really in the middle of the ocean, where they have Mauna Loa, with where they monitor the change in CO2 concentration, or where they monitor the CO2 concentration on this volcano. And they started monitoring this, Mr. Keeling, in 1958, if I'm correct. And this is the, I just downloaded this picture online. You see the website underneath of the last week. And the dark dots are the daily averages, and the gray dots are the hourly averages of the CO2. Now, it seems to be constant. If you look at the last month, it still seems to be constant, but it's slowly increasing again. And here we see the last year, from November 2020 up to November. This is the 8th of November, so 2 days ago. And especially if you look at the next slide, where you see this, this graph with a slowly increasing slope with the CO2 concentration. Vertically, we see the CO2 concentration in parts per million. So the number of 450 parts CO2 compared to a million other parts. And what we see here, and that's always what intrigues me a lot, is basically the breathing of the biosphere. You see that in the Northern Hemisphere, in wintertime, the leaves start to color, they drop off. That's what we monitor with our campaign. And then plants they end their photosynthesis. So they stop taking up CO2, which they need for their photosynthesis. And then the CO2 concentration starts to increase up till about April, May, and then it starts to decrease again when the trees get their leaves, when the earth becomes green in the Northern Hemisphere. Up till September and October, and then it starts to increase again. So this beautiful cycle is an ongoing process. And this increase, if you look at the whole series, this increase is caused by our emissions as human beings. But this up and down is caused by this the activity of the trees. And that is, of course, what we monitor. And we want to see how the spatial dynamics is taking place. And that's one of the reasons why it is important to have a better understanding of how different trees and plant species respond to changes in temperature. And what I understood is that this amplitude, so how much it goes up and how much it goes down, that this amplitude is increasing because temperature is becoming higher, which means that plants starts to grow quicker, the production increases, and because of an increase of CO2 concentration, plants also start to grow more. So they can take up more CO2 throughout their growing season, but of course the leaves drop up again, and then all this CO2 is in the end released later on. So because of the higher production of the trees, it not necessarily means that it will solve our greenhouse gas problem. That is what we see in this image. Now, you can even look further way back in time. With ice core measurements, you can go back 800,000 years in time with the CO2 concentration. And there we see, you're probably familiar with this picture, but the CO2 concentration varied between, what is it, 160, that's in the ice ages, to up to, let's say, maximum 300 parts per million. And now we are already way above 400. And by the end of this century, who knows how high it might be. Hopefully there's effective in Glasgow, but it's still to be seen whether we can stop this process. And so you also see that we are far from natural variability, far out of this range. And it's very interesting then from that perspective, or with that perspective, to see how plants are responding. And that's why we need to monitor this timing. Now we see, and you can make these kind of graphs for your own country, of course, the average annual temperature in the Netherlands, this case. We have temperature recordings since 1706. With the blue lines is the annual average temperature, and the black line is what we call normal. Yeah, that's what meteorologists say. 30 average is normal, and every day it shifts one year. And why 30 years? Because that used to be enough or a good measure to say what is normal. But you see in the past, let's say 20, 30 years, we see this increase of this black line. So what we consider normal now in the national news, when we have the weather reports, when they say this month was so much degrees warmer than normal, then this normal is already way higher than it used to be 50 years ago. These yellow and red arrows are the phenological data that we've got since 1878, and also in halfway last century. And I started this again in 2001 in our country. Interesting. All the observations we make, you make also to this year, are very relevant also for future studies, because we have a good reference to look back. And if scientists or the children that participate, who become our future colleagues, if they use this data again later on, it can be more and more valuable. So that's what we do. We look at the change in the timing of all kinds of seasonal events. And of course, we're now in this beautiful season, which is called autumn. I really love it to go outside and to see all those colors. And I love to use the GrowApp. I created it myself, but I have maybe over 80 different locations where I make pictures. I try to make it twice a week. And this is in my garden, in different parts of the season. So in spring, summer, autumn, and winter. And that's, if you keep on making these series, and I've seen some very beautiful ones all over Europe, long series, then you can make these kind of beautiful seasonal overviews. So here you see an example of all the locations where people, not only me, but also colleagues, students, have started time series in the vicinity of Wageningen. And this number 426, that's where the campus is. And this 122, that's where my house is. So you can see where my action, and you can even see my cycle route to the university because of all the locations where I made those pictures. But also on a European scale, we see many different locations where people make these time series. And that's a beautiful source of information for further analysis. Still much to explore there. Also, I think we need to develop image recognition and automatic processing of data, but that's still to be done. but many series provide a beautiful reference for research to see how the timing is changing because of change in temperature. And why is this globe campaign important? Why is this leaf coloring important? And I just summed up a number of reasons. I'm sorry. It's the end of the growing season. So it ends the productivity cycle for this specific year. So that's why it's important, as I just explained, with the carbon cycle, the CO2 cycle. But of course, when you have leaves on the trees, it's also influencing the heat balance of the ecosystems. Sunlight can reach the ground floor again when the leaves are gone. So it does something with this whole ecosystem. Also with the water balance, because when they have the trees have leaves, they continuously evaporate or water, and that stops also. If they're too late with dropping off their leaves, there are still questions. What does it do with the frost resistance? It's one of the reasons is getting rid of the leaves, because then they will not dry out when it starts to freeze. But we see large changes, at least in the Netherlands, in winter conditions. And what is the impact of later, because that is what we see in the Netherlands, a later start of autumn? How will that affect the vulnerability of trees for frost, but also pests and diseases? The leaves itself, also on the floor, on the forest floor, for example, in your garden, provide a very important source for food, but also shelter for many organisms, plants, but also birds, many insects, and you name it. Storm damage may be something you not directly think of, but the longer the leaves stay on the trees, the higher the risk of storm damage, because trees are able to catch more wind, and that's what we've seen also recently in the Netherlands with severe impacts of storms. And even some things like delay of trains. When do the leaves start to drop off? And that's when the trains have problems with their with the slippery rails. Some other things like green maintenance, but also recreation and health. So people really enjoy the season and enjoy the coloring. So that is also a field of research that I think we still can explore in the future. Now, going back to autumn, this is the current situation. In the last month, the locations where observations were reported via the GrowApp. And there are really beautiful pictures that can be found. And I every now and then really enjoy just going through and clicking through all those images and of this beautiful season, in this case, a birch tree. Here again, I didn't know exactly where the previous one was, but this is in the Ukraine, also a number of birch trees standing together in a beautiful color. It's becoming interesting if you really have a long series. And here I just combined a number of pictures. This is from Croatia. In 2018, there was a beautiful series, and in 2021 again. So to the left, you have the 6th of October and the 3rd of October in 2020. Then 23 of October 2018 and 25th of October in 2020. And you can see the difference, or not so much difference, between the 2 years. And that is a wonderful source for further analysis. How do the different years differ in timing or not differ in timing? And can we explain it also? An example from the Netherlands, this is at the university where I work in that building. A horse chestnut tree. It's not part of the European campaign, but I already started monitoring this in 2014, if I remember correctly. 2 horse chestnut trees and in the beginning of October. And you see from 2016, 17, 18, 19, 20, and 21. And this year we have quite a late year. Not as late as 2016, because that was even a warmer autumn. But this year is one of the latest autumns that we've experienced in the past years. And that's because of the high temperatures in especially September, but also October. It is an oak tree very close to my house, where at the school yard. Again, it's today. I just made this picture this morning, the 10th of November 2021, and I looked up the pictures of the earlier years from 2016 when we were developing the GrowApp. It was launched in spring 2017. At the moment, 285 pictures in a row, and again a beautiful source. And again, although there are now some bushes before they grew quite substantially, but you can see that it is a late year, and only the past days it started to color. The coloring started to become more rapid, and you can visualize it in all sorts of ways. What I do with the number of locations, I also count the percentage of colored leaves, and here we see pictures from 2015. The lines, and the dark blue line and the thick line is of this year. And you can see that it's already, the coloring started a little bit earlier than in 2016 and 2020, but then it delayed because we didn't have frost. And then only late in the season, it started to increase. And then, yeah, it's a beautiful way to characterize the timing of autumn. And you see that this is a late year, but 2016 was a little bit later than this year. Oak trees, less colorful, but still a wide range of colors present in this tree. So that brings me to the end. So I try to make clear by this global carbon dioxide cycle over time to see the importance of the biosphere. The start and the end of the growing season is very visible in the CO2 concentration. And there is much to explore of how individual trees respond to the changes in both CO2 and temperature, and how it interacts with the carbon balance. That's something to explore more in the future. I hope I showed that there are many different reasons why the timing of autumn coloring and leaf fall is interesting. And I gave you a number of examples of how you can analyze these data, especially if you have long-term time series. And I hope it can give you some inspiration to continue your valuable and important research and observations. And I hope that in the future we find many opportunities to use the data even more than we do today. Thank you very much for your attention. Are there any questions?
Yeah, thank you very much, Arnold, for your presentation, and even for inviting us virtually to your garden. It was very interesting for me also to see that there are pictures in your presentation that we have their authors here with us. We have Ankita Veselic from OS-Bania, which is the author of one of the long lines. So yeah, it really connects with the audience of today's webinar. And yeah, it's enough talking from me, and please, if anyone has any question. You can write to chat, or you can unmute and just talk to us.
Do people have an idea on how early or late autumn was in their country this year? It was late in the Netherlands. Did you experience the same in your country?
Hey, this is Brian. In the United States, where I am in the state of Maryland, we are just seeing the colors changing on the trees right now. It's only been happening for a couple weeks.
And is that late, or is that yeah? It late.
It's a little late. It's a little late. You know, maybe by, I'd say, late by a couple weeks. So yeah, it was strange because a couple weeks ago we traveled from Maryland with the geographics here is Maryland. We traveled north through the state of Delaware to Pennsylvania, and there was a line in Delaware where it went from basically summer to fall. It was the leaves literally changed in it was almost a straight line where all of a sudden the leaves started changing in Delaware.
Okay.
Just a little north of us.
Probably a kind of frost event there.
Yeah,
Because we see if you have a first night frost, then it really starts to take off, and then it really makes a difference. I think there was a question about...
Hi, Arnold. Yes, from me.
Yeah.
I was wondering whether you would be available for a presentation for students, for Maltese students, as part of my Shroplagine program. Maybe this year, maybe in the future. What about that? Because this was an interesting presentation. It gives a lot of pictures. It gives a lot of graphics, and those would appeal to students, those would speak to students, and they would be more engaged. Even the teachers would be more interested to participate in such initiatives involving globe measurements.
Yeah, that's something I think that we need to discuss with Lena and Dana to see whether we can organize something maybe also for school children. So because you can imagine that I cannot give a presentation for every school because that will...
No, for sure not for every school. That would be something on a national level here. I would invite the schools, and it would be a one-time webinar for all.
Oh,
logistically.
Yeah, if I may step in, we will be happy as a coordination office to get you in touch and somehow start the communication on this.
Yes, we communicate about it later on. Thank you.
Yes,
okay.
Thank you very much. And we have two more questions in the chat. One is from Marcus. What exactly did your diagram show with the color lines? Coming back to the presentation.
Can quickly get it again. Let's see where I can. This one.
Yes, the one.
What you see here, the different lines represent the different years. So the light blue is 2015. The purple one is 2018. And at the different times in the year, I counted on 10 locations of the tree. I counted the number of leaves that were colored per 10. And if you sum them up, then you have the percentage of colored leaves. And I start in August. And if you keep on doing that once or twice a week, then you can make these kind of graphs of how quickly the leaf coloring is changing. Of course, you can also use the pictures by analyzing the colors of the greenness, but this is the more manual approach. I hope this helps answering the question.
Marcus, in case that you have any more questions, please just talk. You can unmute and talk to us. And seems not. Then we have a question from Juliet. If you make a link to precipitations as well.
I analyzed the timing of leaf coloring. Although the leaf coloring is still a difficult thing to explain what exactly is influencing the timing, because it already starts with the timing of leaf unfolding. And you have the drought and weather conditions throughout the growing season. You of course have frost, you have wind, you have rain, so that all influences the amount of leaves on the tree, the timing of leaf coloring, etc. So far, I didn't find a real explanation of precipitation on timing, although drought throughout the summer might have an impact. But in the Netherlands, at least, especially temperature in September and to a little extent in October is the most explaining variable. But precipitation is not very clear in our country. Yeah.
Thank you, Arnold. And we have one more question in the chat from Bara, who asked if there is any special impact that early frost can have on the tree phenology, leaf falling off or coloring.
Yes, frost. Yeah, why do trees leave their tree or drop off their leaves is that they want to prevent to dry out throughout the winter. So if the soil is frozen, they cannot take up water anymore. So the first frost is a signal to the trees that they have to stop the production of how do you say that? They have to stop the production. So they will form this this layer between I don't know the English name, between the leaf and the trunk, so that the leaf can drop off. It also stimulates the formation of certain colors, the red colors, the orange colors, the yellow colors. So it's also an interaction between the amount of sunlight, the temperature levels. It's a fascinating mechanism. So the intensity of the color is also influenced by the amount of frost that you experience throughout autumn. Mm-hmm. But don't ask me more specific details because I'm not, I don't know those.
Thank you. It was also very interesting. That would be also my question. So it was very interesting to hear. And we have one more comment in the chat from Thanos. That it would be very interesting to have GrowApp data from the southern hemisphere when crossing autumn season in Europe or northern hemisphere. I'm not.
The more people that join from all over globe, the more interesting it will be, of course. Yeah.
Yes, I can say that we have sometimes even schools joining from very different parts of the world, like from Kenya this time for the European Phenology Campaign. So time to time there might be also opportunity to get in touch with or see the measurements from really different continents and different parts of the world. Well, I don't see any further questions in the chat. I don't see any raised hands neither. So thank you very much, Arnold. It was truly a very interesting presentation, very interesting information. And I would like to give word now to our second speaker, to Brian Campbell, who will talk about connection between the school observation, between NASA research, and about the trees around the world campaign activities and plans.
All right. Thank you, Lenka, and thank you for the invitation. It's great to see so many familiar faces and names. Some of you I don't know, but a lot of you I do, so great. And yes, so I'm going to go ahead and share my screen. Does that look good on your end, Lenka?
Yes, perfect. Yeah.
All right, thank you. So yeah, so I'm going to talk a little bit today about NASA, trees, and the GLOW program, Observations for All Research. And, you know, I'm the lead for the Trees Around the Globe Student Research Campaign, and I'm based at NASA in my 21st year at NASA. Prior to NASA, I was a high school, a secondary science teacher for 4 years back in 1997 to 2001. And then I came to NASA in 2001. So I'm a NASA senior earth science specialist. And as you can see here on the left, you know, I work with a lot of different programs leading several efforts. So, you know, what you're seeing here on this really busy graphic is just from the GLOW visualization site. And this is a combination of tree height observations and tree height photos from around, you know, the Europe Eurasia region. So it looks like there's a lot when you look at it like this, but as you know, the further you zoom down, the more open space you get. So this is the one thing that we're trying to do with a combination of, you know, the GLOW program, the NASA Globe Observer Trees tool, which I'll talk to you about in a couple minutes, and then also the Trees Around the Globe Student Research Campaign, is to fill in those gaps where there might not be data. So we are going to look at tree height, tree height, and basically why it's important. So, you know, a couple things I like to share here is that a couple talking points, you know, like when you may be talking to your students or just your next door neighbor or someone, you know, why trees and tree height is important. tree height is the most widely used indicator of an ecosystem's ability to grow trees. I like to mention this in just about every presentation I do related to trees. Think of it this way. Let's think of two areas on the planet. Let's think of the Sahara Desert and the Amazon rainforest. Sahara Desert, not a good place for trees to grow. So therefore you don't get trees with much height, if there's any trees at all. And why is that? Well, because it's dry, it's arid, there's not much precipitation. The soil is sand, mostly sandy soil, so not very organic. So it doesn't have the nutrients needed for trees, to grow and go through photosynthesis. So not a good place to estimate an area's, tree height. But then again, conversely, you can look at the Amazon rainforest. Lots of trees, lots of tall trees, trees are flourishing there. Well, that's a great ecosystem to grow trees because we have a great amount of precipitation. We have a nice climate, a warm, humid climate for the trees to grow. We have very rich soil, very rich organic soil, primarily called humus. So that's a great thing. And so where you see trees that are growing, plentifully and tall, that is an ecosystem that really is conducive to growing trees. Tree height also allows you to track the growth of trees over time. For instance, in my side yard next to the driveway, we have two trees. We have two crepe myrtle trees. We planted these as saplings about 9 years ago, and they were only about 2 feet tall when we planted them. We planted them equidistantly, from the driveway on either side of the driveway. Well, one of those trees is about 16 feet tall now. The other tree is about 8 feet tall. They were the same height when we planted them, but then I was trying to figure out, well, why is one growing a lot faster than the other? Till I realized that the one that is shorter, the one that's about 9 feet tall, that one sits in about 5 hours of shade. It doesn't get direct sunlight because of our home. Our home casts a shadow on that tree. The other one that is growing, that's about 16 feet tall, that tree basically, gets sunlight all day long. So that's something you can track. So, everybody has seen a tree like in their locale, in their environment, where they're like, hey, that's really growing faster. That's not growing at all. By measuring its tree height, that can help us understand, how these trees are growing over time. Simple concept. One of the most important things for science about tree height and tree circumference that I'll mention is that it helps us understand the gain or loss of biomass. It helps us calculate how much carbon is being pulled in and stored or sequestered by trees over time. Basically, a combination of tree height and tree circumference, you can figure out how old a tree is and how much carbon that tree may be pulling in from the atmosphere, through photosynthesis. And then we have NASA missions that look at tree height from space. You see the satellite here. This is the ICESat-2 satellite, which I'll get into in a second, a little bit more. But this mission here basically fires laser photons from the satellite, which is about 498 kilometers above the Earth's surface. And it fires off laser photons about 10,000 times per second. And what they do is they bounce off of the surfaces. They bounce off of the ice, like the ice sheets in Greenland and Antarctica. Glaciers, it looks at the height of buildings and cities and sea surface height. But the thing that we're interested in for this purpose is it can estimate the height of tree canopies across the planet. So it's a real important mission for NASA and for helping us understand how trees serve as indicators to climate change. All right. So with the Trees Around the Globe Student Research Campaign, there's a tie-in. The ICESat-2 mission measures tree height from space as one of its objectives. We have the Trees Around the Globe Student Research Campaign that just entered year 4, and we started the campaign with the launch of the ICESat-2 satellite on September 15th, 2018. So here's a link to the Trees Around the Globe Student Research Campaign, but I'm going to talk a little bit more about the campaign right now. Here we have, this is our core campaign team. We have on the lead, you may know Peter Nelson. He is a Globe partner and online tool and data expert from Oregon State University. He is also the NASA Globe Observer land cover science lead. We have Peter Falcon, which a lot of you may know because he is a partner with Globe and works with Globe countries and regions across the planet. We have Dorian Janney, and we have Dr. Christopher Schumann, who are emeritus, so they're not, you know, as active in the campaign right now because they got pulled to other things with their work. So this is our core campaign team. So let me show you this cool little promo video about the campaign and how it ties into trees and the ICESat-2 mission. As you noticed mentioned in there was that you can compare the globe data of tree height to data from the ICESat-2 mission, the Ice Cloud and Land Elevation Satellite mission. I will show you how I've done that and how you might be able to do that. But one thing I want to mention here is, and one of the reasons why I'm here is that with the Trees campaign, we are always looking at how we can have cross campaigns collaboration. For instance, you know, we are working with several of these campaigns, and you might be part of many of these campaigns. Of course, we have where we're here today, the European Phenology Campaign. We also work with Globe Mission Mosquito, and then also the Urban Heat Island Effect Surface Temperature Field Campaign. And basically, the objective here is, for instance, with the European Phenology Campaign, and you know, Lenka and Donna and Bara are an amazing team that has really emphasized the need to, when the participants for the European Phenology Campaign are out taking observations of green up, green down and the carbon cycle, to also take some observations of tree height, because we want to know everything we can about the environment around us when we're taking those observations. And you know, also with the Urban Heat Island Effect, we're doing the same thing. When they're out taking surface temperature, you know, measurements in urban environments, if there's a tree nearby, take a tree height observation. Globe Mission Mosquito as well. You know, when they're out looking for mosquito larvae and potential mosquito habitats, there are things called tree holes or knots in the trees that can collect water and serve as potential mosquito habitats. So we want, you know, all these things happening, you know, in the environment to be documented. And this is a way we can do this with the cross-campaign collaboration. So, you know, our team for the Trees campaign have met with the European Phenology Campaign folks, and there's a combination of things that we're going to do, you know, in you know, collaboration. One is, you know, really focusing on the role of trees in the carbon cycle with these simultaneous tree height and greening observations. Also, the importance of trees and greenings in the context of the urban heat environment, which brings in that surface temperature field campaign, along with the European Phenology Campaign and the Trees Around the Globe Student Research Campaign. And then because the Trees Around the Globe Student Research Campaign this year, for year 4, is focusing on regions of the Globe program, we're going to, you know, tag team even greater with the European Phenology Campaign in spring of 2022, when they have the, you know, the spring, you know, green up campaign that's happening for it. So, you know, we're really focusing on these cross campaign collaborations. So as you see here, this is just kind of a rough sketch of, you know, what we're focusing on, the regions that we're focusing on with the Trees campaign. So one thing I like to show you here is that this is just something related to the Trees Around the Globe Student Research Campaign, but it's something that any campaign and any participant and student, educator, citizen scientist can use. It's when they look at a photograph, you know, whether it be one taken for the Globe program or even like a satellite image, to try to identify all the characteristics you see in a picture like this. So, you know, just as an example, and you can just think about this while you're looking at it, you know, you can put it in the chat if you like. Basically, looking at a picture, what are all the things or characteristics that you see in the photograph? Okay, that happens to be my son there. This happens to be in California. This is in Yosemite National Park. So, you know, what are all the things you see here? What types of land cover do you see? Do you see trees? How many different types of trees do you see? And also, do you see shrubs, grasses, barren land, the barren land meaning like rocks and things like that? And do you see mountains? You know, when scientists identify pictures in their research, they want to know everything that they see in these pictures. And this is just something that, you know, we're focusing on for the whole data literacy concept that GLOBE really emphasizes all the time. They've been doing a lot more recently. Anybody can take the data, but really focusing on what they're seeing in a photograph or a satellite image is super important to helping understand what's happening in that local environment. So with the Trees campaign, we are focusing on 2 online tools that students can use to look at comparisons between GLOBE data and satellite data. And one is looking at tree height and tree cover with the global forest canopy height tool. And this is the link that we're going to focus on with our campaign for this year. Also, a tool called the Global Land Cover Viewer, looking at land cover. So it's an idea of you go out in your environment and you look around and you take an observation. You say, you know, your hypothesis, you know, do I expect to see trees? I expect to see trees in my location, or I don't expect to see trees in my location. And then you do a combination of observations with the GLOBE program, and then take a look at these global maps where you can actually, you know, you can select your country, and then zoom into your region to see if your research hypothesis was correct. And there'll be more about this, you know, for the campaign, you know, over the next year. But we're really focusing on this. We're just starting focus on this. We have a webinar, and I know it's on the European Phenology Campaign's page. Our Trees campaign has a webinar next Tuesday so it's next Tuesday, and Peter Nelson, who you saw earlier on the core campaign team list, is going to really focus on these, looking at the tree height and land cover with these 2 tools. So basically, you know, the ICET2 mission is the one that I talked about, is something really, you know, what we focus on with comparing some of the data to the GLOBE data. And with the campaign, we have lots of data coming in from all over the world. So since the campaign began, we have over 90,000 measurements of tree height, land cover, and greenings. You know, the majority of the greenings, those 656 sites you see at the bottom in the last just over 3 years, you know, the majority of those have come from folks here at the European Phenology Campaign. But the reason I show this and I show this at every webinar that we do with the Trees campaign, is that it really showcases the vast amounts of data that students and researchers can use. Now, these are student researchers and professional researchers, like ones at NASA or your local science agency, places like that, or university researchers can use. All that data is available on the GLOBE database. So it's super important that we let people know that this data is out there. So with tree height, we can take this different ways. We can take tree heights using a handheld clinometer, which a lot of the students may have in the Europe and Eurasia region. Then also we have the NASA Globe Observer Trees tool. And here is where all the data is coming from. This is about just over 55,000 tree height observations from over 20,000 global locations since GLOBE began in 1995. But since we started the campaign, we've had a lot more. We've had over, as you saw, that just tree height measurements, over 40,000 tree height observations since the campaign began. So let me quickly just go into, just quickly, the NASA Globe Observer Trees tool, which is this other method of measuring. And it's super cool because it allows you to quickly take observations of tree height using your mobile device. And many of you have already. Just wanted to reiterate this. So the NASA Globe Observer is just another tool to do it. And I have some, example observations. When you take these observations, there's just a couple important things, to measure, in order to do these measurements correctly. And the reason why we show this is because we want you to take as many observations as possible, but do it safely. Make sure you follow the guidelines on the app as well, like holding, when you choose a tree, make sure that the base and the top of the tree is visible to you and you can walk to the base in a straight line with no obstacles. Always keep your cell phone's camera at eye level because those are the angles you're measuring. And if you change that angle, you're not gonna have a correct tree height result. And then also there's a setting in there that if you are sharing a device with someone, and multiple people are taking tree height measurements with the same device, you have to go in and change the current observer's height. And that's just done by this little question mark there when you're in the app. You can go right in there and change that height. And then tree circumference is an optional observation. We made it an optional observation, even though it's vital. It's super important for helping us, as I said earlier, understanding our Earth's carbon budget and how much carbon is being pulled in by trees. But we do realize that not everyone has a tape measure with them or like a ruler with them at all times. So we made it optional, but we really recommend that you take a tree circumference observation when you're taking a tree height observation. So here's some examples of some tree height observations from Europe and Eurasia and land cover. And I show the land cover because land cover basically, trees are land cover. Trees are part of that land cover. So super important. So we suggest when you're out taking a tree height observation, also take a land cover observation using the land cover tool on NASA Globe Observer, and vice versa. If you're out doing land cover, take a tree height if there's a tree nearby. So quickly, I'm going to finish up in the next couple minutes. Is that we have the tree circumference. We talked about that. This is a slide here that you don't have to look at it, but this is just to show you that with the tree height information and the tree circumference information that you get, you can calculate and estimate how much carbon is being sequestered, or basically carbon being stored by trees. And there's a lot of stuff going on here in these calculations, but I just wanted to show you this, that it can be done with that data. And that's what scientists are using that data for. They're using that tree height data, they're using that tree circumference data to figure out, understand better the carbon storage across the planet by trees. So we have the handheld clinometer. You can find that on the NASA Globe Observer page. We have this that you can actually, laminate this, use a dry erase marker, and actually take and calculate the tree height while you're taking the observation. And we have an activity where you can then, compare the tree height observations you get with a handheld clinometer and with the NASA Globe Observer Trees tool. And you can find that I have a bit.ly link here because it was a very long link, but you can also find that in the resource section of the NASA Globe Observer Trees tool. Okay, at the end here, we have a tool called Open Altimetry, and it was created by the National Snow and Ice Data Center. This is the group in Boulder, Colorado that houses and stores all the ICET2 data coming in. It's a huge complex because just the ICET2 data, we have just over 1 terabyte of data coming back from the satellite every day. So when you fire off 10,000 laser pulses a second, that's a lot of data potentially coming back to the satellite. So what we can do is we can do a combination of several things. We can do a combination of, taking the globe data and then comparing it to ICET2. For instance, ICET2 landed a photon, basically a photon on my property here in a wooded area. ICET2, when it did that, it returned the average tree height for all the trees that were in that footprint. When I say footprint is when ICET2 fires off the laser pulses, it releases these photons, right? These laser photons. When the laser photons hit the planet, they are about 13 meters in diameter. So when these 13 meters in diameter, when these footprints hit the Earth, what that number is that's going to be returned to the satellite is the average of all the tree heights it was able to measure in that 13-meter diameter footprint. So if there are 20 trees in that and the photon actually only hit 10 trees, it's going to return the average height for all of those 10 trees. So ICET2 returned this at 19.66 meters. I went out and took observations of multiple trees in this location, and I did an average, and I got 18.93 meters. I actually did this prior to me looking to see if ICET2 hit this location. So as you can see, 18.93 meters versus 19.66. It's not exact, but it is close, right? So this is a group of trees. I also found an individual tree, meaning that in that 13-meter diameter footprint, there was one single tree in that location, and ICET2 measured that tree at 19.13 meters. I went out and measured it on March 15th of 2020, and I got 19.41 meters. Now, I went back and measured it this year on February 3rd, and I got 16.61 meters. Why did I get such a difference? Okay, this is why. Once again, ICET2 measured it July 31st of 2019 at 19.13 meters. I measured it with the Globe Observer March 15th, 2020 at 19.41 meters. On August 4th of 2020, we had the remnants of Tropical Storm Isaias come through Maryland. And in my location, we had winds at over 70 miles an hour come through. And what happened was it broke the tree in half. So as you can see here, the tree has this type of outline, you know, back in March 15, 2020. Now the tree has this type of outline. Okay, you can see the tallest part of the tree was destroyed, was broken. Basically, that tree was, the wind broke that tree, this Bradford pear tree. So tree height is super important because people may look at it and think, oh, that tree is probably the same height. It just broke off the side. It's not. It's almost 3 meters difference. So with that information, we can figure out that, well, because half of that tree is gone, it will not be pulling in as much carbon dioxide as it did when it was full. So that's one other thing you can look at as well. So you can go on this page called Open Altimetry, and I have a link at the end, and see if ICET2 hit your location and do comparisons with this. And if you go to the Trees Around the Globe Student Research Campaign site on Globe, we have some tutorials that can show you how to do this a little better. There's a little, you'll see on the left side, there's a link that says blogs and tutorials and things like that. You know, click on that and you can see all the tutorials that we put together. We also have the Globe Trees Family Guide as part of this, where you can take your journey and your learning information about trees to the next level, where you can follow journeys about how you can ask about trees, learn about trees, observe trees, create products related to trees, all at different learning levels, from the sprouts here that you see where it says Sprout Science Journeys. These are for the very young children. And then we have, you know, just starting off, you know, what we call middle school here in the United States, you know, and then, you know, secondary school like high school and university and adults, where it gets a little more complicated, but you can really take a look at trees and, learn more about it through different things, you know, through STEM. I'm going to end it here with this really fun video, and it's called Tree Puns. So what's cool about this is that this is a fun way that we put together for you to learn how to take tree height observations using NASA Globe Observer Trees tool, and, you know, participate in the Trees Around the Globe Student Research Campaign by providing that data.
Are you a budding scientist? Wouldn't you want to know how tall that tree is?
We conifer you a tool to find out.
You won't believe this, but NASA has a application that uses trigonometry to measure tree heights. Oh, mangrove!
NASA uses satellites to measure forests, but now we're branching out and asking volunteers for help.
Volunteers in over 120 countries can participate.
Stumped about how the app works? There are only 3 steps. First, hold your phone at tactile level and point it so you can seed the bottom and the top of the tree.
Next, lumber to the base and log your steps.
Finally, you can spruce up your location and optionally measure the circumference. It's okay to skip this step if you don't have a measuring tape.
The app takes care of the forest by calculating the sides of the tree angle.
Don't leave the app without sending in your data.
By contributing to this inventory, you're helping scientists seed our trees from the ground.
Hearing your observations with satellite data is intriguing and could transform the way we look at forests.
You can do measurements when you are bored, or make it part of your routine. We'll never get sick of more observations.
So that was a lighthearted way to take a look at the NASA Globe Observer, and this is the last slide. Here are some links, including, of course, Globe Observer Trees Tool, Land Cover Tool, the Trees Family Guide, ICET 2 on Open Altimetry. And if you have any questions about that, please contact me about Open Altimetry, and I can show you, how to go through it. But it's really fun to use. And since each one of your trees is geolocated that you take, you have a latitude, longitude, you can plug that latitude and longitude right into Open Altimetry to see if ICET 2 hit your location and if maybe measured some of the trees that you measured. Now, ICET 2 won't hit every tree because there's things that ICET 2 doesn't like, and one is clouds. If clouds are too thick, the laser pulses can't penetrate the clouds. If they're cirrus clouds, the ice crystals wreak havoc on the lasers, meaning that they get bounced in every direction through refraction. So there's lots of scientists write algorithms to figure this out and try to take into account what they can do when there's a lot of cloud cover, but sometimes we just don't get the data. And then a little bit about the ICET 2 mission website. And there's my contact information, brian.a.campbell@nasa.gov. And thank you so much. And I will stop sharing my screen.
Thank you so much, Brian. Wow, that was a lot of interesting information, resources and plans. So thank you very much for sharing them with us. We are very happy to be part of the Trees campaign and to take part in the future plans. So I hope it will bring many interesting activities for everyone in the Phenology campaign as well. And I also want to say that we will have a recording of this webinar and the materials from this webinar available at the Phenology campaign website. So you will be able to get back to it and see the links and so on. And now, please, if you have any questions to Brian, feel free to write or to talk.
And I put my email in the chat in case you can't think of anything right now, but you'd like to talk more about the Trees campaign or Open Altimetry, ICET 2, land cover, things like that. So, we have expertise all over the campaign and at NASA who, if you have questions or concerns or issues with the app, we can figure that out.
I have a question, Brian, because at some point you have so many things to observe that you have to make decisions. If I had to make selection of trees, are there specific trees that you think are more interesting than others? So if they're standing alone, or if they're in a forest land, or what is there any specific interest or?
Yeah, so specific trees, first part, specific trees, we like for people to measure ones that are very indicative of their local region, which may be good. But then also if there happens to be trees that are invasive to their areas, and then because in the Globe Observer app, there's a comment section where you can include metadata. If you happen to see that there's a tree that is unusual or something that doesn't really fit within your region, you can put that in there. But as far as trees, ones to measure, one of the things that we really like to tell people is that we really like to have a lot of tree observations in a small location, because that adds to what researchers want. They want the data density, especially ICET 2 researchers. They want that data density. And we know that if you go to a wooded area, you may not be able to access or see the base of the tree and the top of the tree from where you're standing or where you can be, because they might be pretty dense. But we like to see as many of those observed and tree heights taken for ones in a dense forested area that you can access that you can, as I mentioned earlier, that you can see the base of the tree, see the top of the tree, and be able to walk to that tree in a straight line with no obstacles. Because, you know, and then once we have all that data in that smaller area, then that can be really, you know, really focused on when the researchers want to do a comparison between maybe the data that they've worked in the field and the ICET2, that what the data is coming from ICET2. Since ICET2, you know, it rarely sees just an individual tree in a photon footprint. It's usually forested area where there's multiple trees. You know, it's just I happen to be lucky that there was one in my neighborhood that I was able to get an individual tree in the footprint.
Okay,
so,
but you more like it if we submit, let's say, 20 or 100 trees at the same time in a specific area than every now and then one tree at a time. Every tree, of course, you like, but
yeah.
No. Okay.
Yeah, as many as you want to do, that's great. Yeah, but that's perfect. You know, many trees as you can in a specific location, because as I mentioned, that adds to that data density which researchers want.
Okay, thanks.
Sure. And I see a question from Thanos. It says, what about taking tree heights in winter season without leaves on the trees? Are these observations more valid? I don't know if the word valid is the right word, but they're very important because they can also help you. You know, there is going to be, you know, with some trees, substantial tree height difference between the, you know, when the leaves are off versus when they're in full bloom, when the tree's in, you know, full leaves and full bloom. You know, for instance, you know, there's a couple trees here that I took observations of where there was probably about a 2 to 3 meter difference in the tree height in the winter versus the summer. So yeah, that's super important. This is a great research project for students to go out and take observations of the same trees in different seasons. And this is all, you know, along with the greening observations with green up, green down. This is such an important thing. So like I said, the term valid might not be the right word, but you know, it's all super vital that we do it in these different seasons to be able to do these comparisons, because when these trees are, you know, these leaves are undergoing photosynthesis during the spring and summer months and towards the end of fall before the green down. But then, you know, in the wintertime, of course, photosynthesis is slowed down or stalled a little bit. Some of the trees, like ones like in the Arctic area, they go into hibernation. So photosynthesis is very slow, you know, at that time. So yeah, so great question.
So we have a time for 1 or 2 last questions. Okay. I don't see anyone with a raised hand. Okay, so I think the time is running very fast. So let's come to an end of this webinar. Brian, thank you very much. Thank you for answering the question and being with us. And before we end this webinar, I have one invitation for you. So I will share my screen very quickly. I hope you can see it well. The invitation is for the challenge called Tree Reporters Challenge, which is running now at the moment. It started in October and it will be open until November 19. This challenge brings you and your students the opportunity to meet your trees from a different perspective, to visit them and make an interview with a tree that you like, that you maybe observe, or any tree that you just find interesting close to you. There are no strict rules for these interviews. You can ask the tree whatever you find interesting. Only we ask you to talk as a Globe Program Reporters team. That is very important for the interview. And think of the fact that the interview should be attractive for those who will listen to it or read the interview. There are 2 options how to make your interview. You can shoot a 1 minute long video for a tree TV channel, or you can create a poster for a tree magazine, which can be done either handmade or in any virtual way. So you are very, very welcome to send us your submission, shoot your videos and create posters. We will be looking forward to see them, and please submit them by November 19. And the results will be presented at the next Phenology Campaign webinar, which is another invitation from me that it will be the last webinar of this Phenology Campaign and will take place on December 1st. So this is invitation from me. I see something in the chat. So, yeah, okay. Dana sent you a link where you will find closer information on the trees challenge, so you can read again. Okay, so
thank you.
Thank you. I think that's the end for today. It was very nice hearing all the presentation and also your questions and your comments. I hope it was also interesting for you and that you gained some new experience and new ideas for your school activities. And I hope to see you on December 1st at the next webinar.